Okay, so again, welcome to Duct Linkage to Outdoors. We're now recording, and I have a few things I do want to kind of promote because this works on both systems. If you have a duct blaster or a duct tester, or do duct stuff, Retrotec has this new clear flange, which is just a phenomenal device for, especially if you're using have your return overhead. It's got little clips that actually hold it in place. You still need to seal it to your grill. But it finally conquered the issue of how fast can I do a duct test before it falls to the ground. And again, it works on either Flex Duct, Retrotec, or Energy Conservatory. So again, sales can help you with that, and these are priced to move. Some other duct sealing options are partners with us. Is I want to make sure we promote Corey Breed at VinCap Systems, and also Duct Block out of California. They both have similar systems that help make your duct testing go a lot quicker and smoother and faster. And you can reach out to them to expand some of your sealing options. So we've been waiting for this day for I don't know how many years, and here it is. Our cloud is now on iOS, which means that you can use it on your Android phone or tablet, your PC tablet, or your actual literally your PC, or your iOS device, which means your phone or tablet. It does not work on a Macintosh. But this is a great breakthrough in terms of where we've been trying to get our cloud to move. And just so we're on the same page, here's what our cloud really does for you. And it's going to, we call it the future of testing, because you're just going to set up like you normally do. You open our cloud, connect to your gauge, run the test, share the report right there. And if for some reason you don't have the ability to share the report, it will store it for you. And when you do have Wi-Fi or access to the internet, it will upload it and allow you to share it. It's an entire platform. It gives you more information on a couple webinars we'll have coming up. But I want to let everybody know that it is on the iOS platform now. So you can now use it on other stuff. Here's a simple screenshot of what it looks like. Again, we think this is going to be a phenomenal resource for anybody who wants to document their own test or share them, knowing that everything was done, geotagged, time, date, stamped, and secured. Okay, leakage to outdoors. So when is it required? We're going to try and cover that, some setup options, some complex setups and alternative tests, so we actually can kind of cover this in a different way. So let's start with how many of you are doing leakage to outdoors. Like you actually, whenever I do a test, I don't even do total leakage. I only do leakage to outdoors. And if you could also let me know is, did the home have used the framing for the ductwork? So that's actually a number one reason why a lot of people will use their leakage outside, is because they can actually pass or get a much better number because the ducts are so leaky if they're actually using the framing as part of their duct system. What's that called, Jay? I forgot the name of that. What does they refer to that as?
Occam's razor.
Okay, there's another word for using your duct system as that. So yeah. Okay, so let's dig into some of these now. If you know of a reason why leakage to outdoors would be optional or required based on your state or other options, then please let us know. So 2009, it was an option. It was taken out in 2012 or 15. If I can confirm correctly, it was brought back in 18. So we're a little ahead of the curve, but it is in there. Many local energy codes, including Georgia, is debating about putting it back in. I know some others have done so also. Many people realize it is actually it's a better test and confirms how well the system was installed. Energy Star, in order to get an Energy Star rating, it is required. HERS rating, depending on where you're at or what your requirements are, it is optional unless somebody wants to correct that. And again, I'm looking for some other ones that are want to know that. Panned ducts, that's the word I was looking for. Panned duct systems. Those are pan ducts, or when you're using your framing as actually a duct system. I'm going to go through just a normal total leakage concept. So you remove the filter. We also remove the filter when we do leakage outside. I just didn't really include it in some of the verbiage, but you do want to remove the filter. Some people leave it in. I just have always used the concept, just remove the filter, make sure that the filter opening is now covered. And we'll go through again what a normal total leakage is. This is depressurization. You need to open a window or crack a window or have a door open slightly, and so that I actually can have normal pressures inside the house. All of the ducts are sealed. I add the flange, I seal that, and put on the flex. I added a new image here, so you may have to connect it to the air handler, depending on your returns or other requirements or other limitations. But otherwise, you may just go ahead and seal it to the return. You definitely want to use the largest return, obviously, near the air handler. Connect my flex, install the units, my gauge. Notice that we have the connections going to the duct tester. We're depressurizing. On the right side, I show the duct tester how it's going to be connected to the flex, reminding you that the ranges always go inside the duct, the flex duct, when you're doing a depressurization test. This is either manufacturer. This is Energy Conservatory and Retrotec. So your ranges, your rings, should be in your flex duct if you're depressurizing. So you want to know what they are. We connect the blue tube, which is the input on channel A, to the nearest return to the air handler. That's the most common process that's there. And we depressurize to 25 pascals. Now I have a variety of leakage. So notice I have leakage indoors here, and I have leakage outdoors. I will use the phrase accidentally outside, but the term usually is outdoors is technically correct, but we both understand that outdoors and outside are kind of the same concept. Okay, moving. Also, at the bottom, I have a variety of results here. The purpose of the results were to show that if I were to flip this around and do pressurization, the numbers should be close, but may not be exactly the same. So it is a good habit to actually do both of these. And with the Retrotec system, you just flip the fan around. There's nothing to change, no tubes to add, no flow straightener, none of that stuff. So if you do them both quickly, you can confirm that I definitely have an accurate number, that I don't have a flex duct that's separating or moving or getting pinched or opening. So it's a really good way. And I also confirmed that my seals that I had around all of my registers were also intact because they get pulled tight on depressurization. They may actually have a little bit of leakage when I pressurize. This is a common concept if you're doing code compliance, that you do not have to test the ducts if the ducts and the air handler are within the thermal envelope. It's not actually conditioned space. They actually state thermal envelope, and that's 2009, 12, and 15. Now, if you're going to do other above code concepts, you definitely should be testing your ducts. But you should test your ducts all the time. It's not that tough of a thing to do, and it's one of the ways that actually we all see a lot of energy loss in a lot of comfort conditions that happen because people are not testing and sealing their ductwork. So I wanted to again make sure we're talking about pressurization versus depressurization, what the fans look like, where your rings are, just so we're all on the same page. We do have some illustrations that Jay has thrown into your handouts. So your handouts have a variety of stuff that deal with the manual for the duct tester, some quick guides, and one of the quick guides is an older quick guide, but it actually goes through this whole concept of these illustrations that I'll have here, including leakage outside. So all you need to do is click on those and you can download those. Okay, so again, airflow, we make sure we're on the same page. Pardon me. So now we're going to dig into leakage outside. When I first started testing, maybe somebody else can agree. Yes, this was seemed like a challenging concept to understand or to explain to somebody else. All right, so I really tried to see if there was a way to quantify this or simplify it so I could explain it during a webinar as well as to others. So one of the things that obviously is required as leakage outdoors is you must have a blower door and a duct tester operating at the same time. We're going to go through some of those options, but here's a illustration that I created that kind of describes that. So think of this as a pipe or maybe ducts with a leak. So my pipes are leaking, and let's just say that they leak a normal amount. Let's say they're dripping. They could be dripping water. This is not condensation. This is actually holes in the actual pipe that's actually leaking. And if I were to take the bottom set and put a container around it, then I now have leakage that's outside of the container. You can see that the water is now moving around the container. And I also have water leaking into the container. Eventually, the water inside the container will fill up, or what we're now talking about is that the pressure will equalize. And then my area that's leaking inside the area in the square no longer has the ability to leak anymore. It is now equal pressure between what's inside the pipes and what's inside the container. Meanwhile, I still have leakage outside of the container. This is the concept of leakage to outside. So once I, again, create equal pressure across all of my ductwork, then I actually only measuring leakage to outside. The one thing that is fundamental about leakage to outdoors is both fans are doing the same thing, which means that if you are depressurizing your blower door, you must be depressurizing your duct system and vice versa. So this is a duct test. So some people may decide they're going to pressurize their ducts. So then you must make sure that you are pressurizing your blower door. Okay, so again, they must be doing the same thing. And sometimes it seems strange that we can actually do depressurization, but it works the same as the concept. It's just creating a neutral pressure across a certain plane where the blower door is providing pressure.
So, Joe, quick question.
Yeah.
So earlier you talked about the speed control adapter, which basically allowed you to use, or anybody to use a DM32 to run a Retrotec blower door. Will that also work on the Retrotec duct tester? Or I'm sorry, the Energy Conservatory duct blaster.
Yes, that's an excellent question. And the difference is that most speed controls that TEC has for the blower door have a small port on the side. It kind of looks like a headphone jack. And you need the headphone jack in order to use the Retrotec adapter. It basically just adapts one signal to the other. So a lot of duct testers, though, did not have this adapter on the side. The adapter also allows TEC users to do automated testing and to do cruise control. So if you do have a duct tester, if it has the smaller unit, it probably does not have the jack on the side. If you have the duct tester that's got a much larger controller, then you can see on the side you'll find your port. So thank you, Jay. Great question. Okay, so let's dig into, now we understand the concepts. Let's dig into the leakage to outside. So this is a duct test, and if you're going to, even when you do this for code compliance, the goal is that you're always testing to 25, whether it's pressurization or depressurization. Your goal is to measure the ducts at 25 pascals. That's the common pressure to compare home to house or house to house as you go through your code or compare one home to another. Okay, so let's step through. We are going to depressurize. Okay, so things that have to happen is that if I thought my fan should turn around. Sorry, my fan at the bottom was the wrong fan. Sorry, I tried to go through and vet all of my animations. So what happens here is, so we'll just do this as a concept. Okay, so the concept is I have my fan depressurizing. Oh, it is depressurizing. Okay, great. So everybody's depressurizing. Fan is depressurizing. Duct is depressurizing, which means I'm pulling air out of the duct. So what's going to happen is that I'm going to end up with a neutral pressure in the house, and you can see here that these little arrows in the middle here are going to disappear because I now have total leakage with my duct tester, and when the blower door is on, it will neutralize any kind of leakage that may be happening inside the walls or any other issues where even around some of the boots where they actually touch. So that's actually the concept of what we're going to be talking about and working through here. Same concept is if I'm pressurizing. So I'm pressurizing, and now I have the similar concept. I did not turn my duct tester around, sorry. So we go back to this concept of that I have a blower door and I have a duct tester. And I should have probably made a slide that explains this, but I'll do it the same. So if you only want to do one method, it would be to what's referred to as set to zero. It's a very common method that everybody uses. There are additional options, which I'm not going to try and confuse the language to just yet. So the goal here is that I take my blower door first and I send it to 25 pascals, right? And then I take my duct tester and I set it to zero. One of the things that you have an option on is I can disconnect my speed control for the Retrotec and actually use a knob and turn it. Usually you're going to have pressures inside the gauge. Usually they range from like maybe 7 to 11 pascals. And as I turn the duct tester on, that number is going to reduce and get me down to 0. It is difficult to really get to 0. So usually anything that's considered a 0.5 is really considered 0. So if you're struggling to get to exactly 0, you may spend an extra 5 minutes waiting for that. Meanwhile, your numbers won't change because you went from 0.5 to 0. On the gauge, you have the option of, if you're not going to use a speed control knob, you have the option of actually just taking the gauge and hit set pressure 0. You must enter 0 because when you go set pressure, 0 already shows up at the top, and if you hit set, it doesn't do anything. You have to tell it to set pressure, enter 0, and then the fan will rev up and create the neutral pressure against the blower door and take it to 0, and then you get your results. You cannot use the at feature because you can't use an at pressure when you're dealing with 0. It just doesn't work. So that's one of the drawbacks. So you really need to get close to 0 as you can to make sure your numbers are accurate. Any questions so far?
None so far, Joe. I just want to mention I've been doing a few classes, sort of an intro to gauges and um, uh, digital gauge testing, and one of the things I think is super important for everybody to understand, and especially if any of the people on the webinar now expect to explain this to some of their people in the field, just the idea that this is not an absolute pressure, this is a differential pressure. So when Joe's saying set pressure to 0, he's saying just make sure that there is no difference between the pressure in the duct with reference to the pressure in the house. So they are both, in reality, both the pressure in the duct and the pressure in the house are the same, but since they're the same, there's no difference, and hence this second gauge being set to 0. So I hope that would help everybody else explain it as well.
Oh, sure, Jay. That's great. The problem is that it is such a challenging concept that unless you have some kind of visuals or the ability to use your hands, sometimes I always find it difficult to explain it to somebody. So let's make sure we're on the same page as what we're doing our setup here. So we are doing the exact same setup for the blower door. The blower door has not changed in terms of where the tubing goes. We still are referencing the outside. Retrotec is red through the red panel. And all the gauges, the yellow always goes to the fan. So here you can see the yellow and the green are connected to the duct tester, and the blue is still going to the supply nearest the air handler. So again, so far nothing has changed to do the set to 0, the setup. So it's a very simple process to do that. So if you depressurize your ducts and you clearly going to depressurize your blower door, there's nothing to change. You can just do blower door, and then you can do duct testing or vice versa. In fact, I usually do blower door, and then I seal the ducts, do duct testing, and then I can do leakage outside. So this is definitely a process by which you can easily follow, set to 0, turn the knob to set pressure to 0. Now we're going to move into a different option. Some people may use this all the time. So we've been referring to set to 0 versus the other option, which is referencing the exterior with the duct tester. So the duct tester has been referencing the inside because you putting a tube on the input, which goes to the ducts. The reference has been open, sitting in the house. So the other option you actually have is to take that tube and move it to the outside, and you can take both gauges and set them up to go 25. So you can only do this if you have this additional tube. So you can see the illustrations. These are part of the illustrations of the handouts that Jay set up for you. And these are some illustrations which I'll show in a second, knowing that if I'm going to do this reference the exterior, I now am taking an additional red tube and moving it outside, or at least combining it with the blower door. You can see up here that this is the combination of red tubes. So I have a red tube from the duct tester, red tube going to the outside, and so both my gauges are reading the same reference that goes out to the outside. So anybody do the reference the exterior and take both gauges to 25. So again, on the left is set to 0. On the right is referencing the exterior, and I take both and equal 25. Here's a focus on a zoomed in. So on the left is set to 0. So I got my blower door. I'm depressurizing. Blower door is at 25. My gauge will try and go to 0 and give me a number. Or I reference the exterior. I notice I have an extra red tube that goes outside with the blower door, and these are both set to 25. 25, close to 25, and my results. Whether the results are different is only because I was playing at my house and those are the numbers that I got. So it doesn't mean that one will be more than the other. So again, referencing the outside, I have additional tubing. So what I thought I would do is just go through what some of that tubing looked like and what we actually do from a normal test to a leakage to outdoor test. So I connect my tubing and my speed control to the fan. These are all normal stuff. Blue tube is always connected. And notice that the red is open. It actually has been referencing the inside of the house. We do a normal duct test. Okay, we've actually got a window open. All right. So technically, when we do a duct test, we really are referencing outside. All right. But when I do leakage to outside, I have to close my window because I can't leave the window open in order to get my blower door to work. So a window is closed, and if I want to reference outside, I need to add this additional tube. So hopefully this clarifies the two options that you have. If you want my opinion, I just want to make sure you understood this as a concept. I highly recommend set to 0. Whether you turn the knob or set the gauge, set to 0 is the easiest method to use. I was actually on the fence for a while. I am wholeheartedly set to 0 kind of a guy now. And here's again another illustration of showing what those things were. I thought I wanted to make sure I give you lots of options to see what some of the systems may look like. So the other option that I have is I can use some software to do some of these tests. Okay, so on the left here I have a duct tester. Notice on the right I have a blower door. You can tell by the icon on the gauge. This is virtual gauge. This is actually the PC application. I'll go through some applications here in a few. And this allows me to control multiple fans at one time. You can do this with Wi-Fi. You can do this with Ethernet. I can do this with USB, depending on the distance. So this allows me to be in my kitchen and literally control this process. So I have my blower door and my duct tester. I'm in the kitchen. I can actually control both fans. I can tell one to set to 0. And the reason I put a black line here is that on the blower door, I'm not after results. I'm only after the results that are on the duct tester. So even though this may give me results depending on my range and the amount of leakage and flow I have, the reality is I'm really only after the duct tester leakage. So you do have the option of using the virtual gauge to benefit you. And we're going to talk about what happens when you have to use your duct tester in the attic. This is also another option that gives that to you. I want to go back to a previous slide to make sure we're on the same page. So again, we have a set to 0. I'm going to go ahead and clear these out. So we have set to 0 on the left, or referencing the exterior on the right. Here's one of the big differences, which Jay's going to remind me that I'll add a slide to do this. On the set to 0, you always do the blower door first. So I go set pressure 25. Again, pressurization, depressurization, it doesn't matter. It's just a pressure. So I do blower door first, and then I take my duct tester to 0. The difference is if I'm going to reference the outside, I have to do the duct tester first, because what happens is that the blower door is going to create 25 Pascal pressure in the house. And so my gauge also becomes a similar pressure, and it's hard to get your duct tester to go to 25 because it's pretty close to 25. So unless you do this live, it's hard to really see that in action. But the point is, if you're going to reference the exterior, add the extra tube, take them both to 25, the duct tester goes on first, then the blower door. So that's one thing I want to make sure you understood. Set to 0, blower door first, reference the exterior, duct tester first. Okay, so let's move past that. And all right, so I have a new slide animation for everybody. So let's focus on what happens if my duct tester is in the attic, and what do I do? Any other questions we want to address before this, Jay?
Joe, we did have somebody asked for just a quick review of the at function.
Okay, great. I can do that. Sure, I'll go that. Okay, so we have two options here, which a good question because I didn't mention it. So again, we're going back to this set to 0 on the left. I cannot use the add feature, which is in the upper left corner, because when you actually do set to 0, then you cannot actually turn on the add feature. It just won't even allow you to do it. So I only can get what my actual reading is from the gauge. If I actually do the referencing the exterior and I say bring the duct tester to 25 and the blower door, on the duct tester, you can see here that I can actually use the add feature. So I was able to do a CFM at 25. So I was only at 24.5, but let's say I was only able to get to 23, or I didn't want to wait all day for the blower door and duct tester to finally balance. So I can get my add feature out of this system. To make sure we're on the same page, of the add feature is that if you're testing blower door or duct tester, and I'm not achieving my actual test pressure, that the gauges are smart enough to say, oh, you're at 23, I can give you your results at 25. So this is very helpful on a windy day with your blower door when your numbers are fluctuating from 45, 52, 55, 48. So if you turn on the add feature, it's going to constantly give you your readings as though you were always at 50. I just use it automatically whenever possible. I just turn it on and forget about it. Most of us can get to our test pressures on duct testing because it's usually kind of a stable system. But in terms of blower door, I always turn it on. I turn it on all the time. So hopefully that answered the question of what the add feature was for those who were curious. Any other questions, Jay?
Nope, it's all you. Take it away.
Okay, here's a brand new animation. I know Jay's excited to see a new animation. Okay, so this is what do you do when you have the only returns you have are in the individual bedrooms, or for some reason the central return. Okay, the point is that I have to take my duct tester and go to the attic. Okay, that's actually the point of the illustration here. So it can happen. It depends on your leakage or your method. So this is my normal setup. I have both fans down in the common area where I'm very comfortable and able to do both tests. But let's move into what happens when I have to move everything up. So I'm going to open my attic hatch. My stairs come down. Joe Tester is up in the attic. Not very comfortable. Not the best place to do this, but you can actually connect your duct tester directly to the air handler itself and perform the test. Notice that everything is sealed off, including all of the returns are now all sealed off. Okay, so, but in order to do leakage outside, I cannot have my attic open. I need to pressurize the main area, the main envelope downstairs. So in order to do that, I need to be downstairs, close up the attic, and be able to run both tests. Meanwhile, my duct tester is in the attic. You could actually run a speed control down with the tubing and have your gauge downstairs, but that's kind of a challenge for your attic hatch. All right. So my goal, I want to make sure that that's sealed and my blower door has no challenges reaching its pressure. I go over the blower door. I turn it up to 25 pascals, and now I can actually use my app, which is the gauge remote, and control, or you could also use virtual gauge and control the duct tester from downstairs. So this is really where Wi-Fi comes into amazing play and gives you options on how you can actually run your test. So a simple animation, but the point is that if you do need to have, again, maybe your blower door is also not accessible in order to do your duct tests. If you are looking for one way to control one or the other, you can use gauge remote. It only will control one fan. That took like 6 hours, and it only took like less than a minute to show everybody. So animations are fun, but it can be very challenging. Yeah.
Great ones make it look easy.
Yeah.
So real quick question about that. We did have a very good question. So just had a question that said, do you mean the supplies are sealed off when you said the ducts are sealed?
Yeah. So let's go back to a couple examples here real quick. That's why we have these phrases. So in this example, I'm actually connecting directly to the air handler in the attic. Okay, the air handler could be downstairs. The point is, if you're going to connect to the air handler, the entire system must be sealed. Otherwise, I can't create pressures in it. So connect the air handler, the entire supply and returns are sealed. Let's go all the way up to the top here. And here I'm connected to the return. So the only thing that's sealed is that I'm actually connected to the return, and I've sealed around the flange. So the difference is that if this return was in the ceiling, it would be the same concept. But if I was going to connect to the air handler, then anything else where air is moving through the system must be sealed off directly. Let's say I had another return. In fact, let's just assume that this upper right register is also a return, then it also must be sealed. So the point is that in order to create pressures inside your ducts, it needs to be sealed everywhere except where the duct tester is connected. Okay, this is a different method. This also is leakaged outside. This is actually the code compliant method in Kentucky. This is something that a lot of home performance professionals use, not necessarily for compliance, but this is how they'll go in and measure duct systems themselves. It's a very simple path. Many people that do home performance do not own a duct tester, but they measure duct leakage and actually quantify it. So the process is that I'm going to use my blower door. Pressurize the same way I normally do is one option. If you're going to depressurize, then you must have a powered flow hood. Okay, and the reason is that these are really low pressures that I'm reading, and this leakage is what comes in from anywhere from your attic. So as I depressurize, I have all this air that moves through, and I can measure this with a flow hood. When you're measuring supply with the flow hood, especially low flows, it can be challenging with an average bolometer. So this is actually a powered flow hood. Jay can throw out one of the, he'll be right now tracking down the handout for the flow finder that Retrotec sells, and he'll throw that in your handout. So look for another handout here in a few minutes. So the flow finder is designed to do incredibly low flows, 10 CFM or less. It can do it. It'll state that it does 10, which is a phenomenal measurement, but I've seen it actually do less than 10. So this is one method. The method that most of the other folks use is to actually just use either a powered flow hood or an average bolometer. And what it's going to do is you're going to pressurize the house so that now anything that moves through the flow hood is now going to the outside. So again, this is a leakage to outside test. So you can use your flow hood while I'm pressurizing the house and can go around and measure different areas. So as you can see that I'm pressurizing the house. All of the ducts are open. All right, see at the bottom, these are open. They're not sealed. So this is different from a duct test. I want to see how much air will move through the entire system and go to the outside. So I got my blower door on. I'm pressurizing to 25. Even the return is open. Everything is open. And now I go around to this first register and I can measure 60 CFM. I can go to the others and measure 85. And the goal is to try and determine. So again, this is 85 CFM leakage outside. And I got the last one, which is 75. So I can actually do a total leakage by also to go in return. I do 125. So I can say that this system is leaking 354 CFM. And based upon that leakage to the square footage that it serves, gives me a similar concept as we normally do our duct test in terms of a CFM per 100 square feet. Again, this is a compliance method in Kentucky. Others may or may not allow it. But again, this is just a concept on another way you can measure leakage to outside. Home performance people use it because they don't have to connect. They have to seal all the ducts, number one. It's a lot easier to get to the registers, but may not have to seal them. And they can do a great job of measuring this and know which ones to focus on and give their clients quick information by just setting up the blower door. And also when the blower door's on, I flip it around and do depressurization, and I get leakage with the blower door. So I get envelope leakage, flip it around, do a quick bolometer test with my registers, and I can tell a lot about the total leakage of the ducts in the house itself. So making sure, is that question? Yeah. So the only on this system, the only thing I don't seal anything actually. So all of the system is in its normal operating condition. It's off, but it's in its normal operating condition. Nothing is sealed. Okay, the other one, which I'm not fond of, it is also code compliant in Georgia and a few other places, is referred to as the blower door subtraction method. All right. The concept is that the ducts are open; they are not sealed. I do my blower door. I measure 1250 CFM, and all of the system is unsealed. Then I say, okay, let's seal the system and do the test again. Again, I seal all the returns. I seal the entire duct system that I can get to. And now I've got 1025 CFM. So in theory, I'll use the word heavy on theory. In theory, um, the duct leaks 225 CFM. If you're going to use this, it's referred to as the unmodified subtraction method. It's kind of like, this is definitely a shoot from the hip kind of a concept. If you want this to be a little more accurate, there actually is a modifier that you use. And actually, when you have the test going, I actually, during this test, when I actually have everything sealed, you take your manometer and you throw a tube up into one of the ducts and you find out what's the pressure difference. That pressure difference creates a modifier. So you can see on the top of your house to duct pressure taped off, and there's a whole simple math that goes along with it. It's not as complicated as it looks, but it actually gives you a correction of what it is. It's really not just A minus B equals C. There's actually kind of a correction to give you a better factor in terms of what is your subtraction method. So you can see that I normally would have had, according to this, I went down to 120, 159 CFM. So if you're going to do it, you definitely want to follow the factors that go along with it. Pressure pan. Let's do a quick thing on the pressure pan. Pressure pan is leakage outside. It's the same concept. It's just not quantitative. It's diagnostics only. If you're not doing pressure pan when you do your blower door, and you know you're going to do a duct test, then you only make your job harder, because the duct tester says, I've got 450 CFM leakage. I don't know where it is. I just know that I have 450 CFM of leakage. Your pressure pan can actually isolate where that is. So again, it's diagnostics only. So we're going to use our pressure pan. We're going to connect it to the input on channel A, which means that I don't really care about what's going on channel B. It doesn't matter what device I've got there. All that doesn't matter. So channel A is going to give me my actual results that I can use to compare. Most people use the rule of anything above 2 needs to be addressed. Anything above 4 is a serious issue. So sometimes you may get stuff that's around 1 point something. Usually those are considered to be normal leakage. If you want to get below 1, you have a really nice, typically considered a good duct system. So again, we're going to do the same concept. We use the blower door again in order to create a pressure difference that I can measure. Here, though, we're measuring it at 50, because we already did the blower door at 50. We're going to measure the pressure pan at 50. So again, this is just a diagnostics tool. If you change the blower door to 25, then my numbers of saying above 2 is an issue will change, because my pressure that I'm measuring from also changed. So for right now, we're going to say we're using 50 pascals, because that's how I do the blower door, keep it running, and I start running around and going, 0.9, that's great. I move over 6.8. I definitely have an issue in this duct system. And I go to the last one and say 1.1. So great. So I know that that second run was an issue. So this actually is my problem area. Oops.
So Joe, does your animated character, is he actually using 2 gauges?
No, it's a good question. It's just showing that he's holding one. Oh, well, there's 2 gauges. So there's a gauge at the blower door, and right now there's a gauge at the pressure pan. Do I need 2 gauges to do this test? Great question, Jay. Is actually no. And so again, if my blower door, if I took that gauge off the blower door and just let it run by using the speed control knob on it, right? So there's a knob on the fan for Retrotec. I can just use that to rev it up to 50 pascals and then take the gauge and walk away, right? So I usually have that option to just use 1 gauge to do this. I usually can tell if my fan had a slight shift just by listening to the sound of the fan. Is it going to be a grave issue if my fan suddenly became 48 pascals or 52 pascals? Not really. I'm doing a diagnostics concept here. So my goal is that 1 or 2 pascals, slightly different on my fan It's just giving me an indicator as to what's going on in the duct. So it's not going to be into the world. We're not going to Mars. Clearly, I can always go back or run an extra tube to the outside and drag it around with me if I want to find out if I'm still at 50 pascals.
Yeah, Joe, I would say just to add something in here. There are some programs out there, and in fact, Illinois Weatherization being one of them, who do have specific, who use the pressure pan and actually are not thinking of it in such a roundabout qualitative a way. They're thinking they actually have specific amounts of Pascal leakage that they allow. So in those cases, yeah, it does make a big difference. And I would suggest that they do actually have two gauges, one to maintain, one that you can actually, one DM32 you can put on the fan and make sure that it's holding the building, the inside of the house, or the manufactured housing or site-built housing at 50, and then taking another gauge, maybe an older gauge or even a DM32, or I'm sorry, even a DM2, to actually do those tests. Or, as Joe said, if you look at the schematic that Joe has right up on the screen right now, you have this blue tube that's connected to the gauge, but the tester has the gauge in his hand. You could potentially take an extremely long piece of tubing, connect it to the gauge that's actually connected to the blower door at the front of the home, and then use a virtual gauge or gauge remote, which are the two, one being a mobile piece of a mobile device or mobile app on your phone, and then watch as the gauge changes as you walk through the house. So again, that's just a different way of looking at it. If you are very, if it does matter to you how many pascals of leakage you have when you're doing the pressure pan.
A great point, Jay. Now, one more thing you can add to it. So Jay was describing that if I had two gauges, I can actually watch one gauge on my phone or tablet. The other option I have is that you see that I have channel B here, which has no connections, and I said we don't care about it, but I could actually run a tube all the way outside, and I can actually see my pressure on channel B. And if it was not at 50 pascals, then I go back over to my blower door and adjust the knob. So there's a variety of ways to monitor this with a single gauge. It's always easiest with two gauges, but you can do this with a single gauge. So I know that this actually is my greatest challenge I have with this one duct run. And a good example is, let's say that I have two bedrooms at the end of the house and they are split off with a T, and I can see that one is leaking 7.2, definitely an issue. The other one is leaking 7.2. Based upon the fact that both of them have a similar number, I know that the actual leakage is here where they both connect. If one of them was 1.1, then I would know that it's the one that's 7.2 is between the connection and the run itself. So the pressure pan can actually do some very pinpoint diagnostics as to knowing where the pressure difference was, as to where I need to go in the attic to actually fix the leaks. All right, let's see where we're at here. All right, I'll do a couple quick testing apps. I do have a cool animation that I want to do with SketchUp, so we'll go through this. So this is mostly focused on using the Gauge Remote app. So the Gauge Remote app is something that a lot of people actually are doing. I've heard about this as being a more common method, that they turn the duct tester on, they turn the duct tester off. They actually can do the seal on the fly, kind of a concept. So you can use the Wi-Fi. The gauge must be Wi-Fi, and it can also create your Wi-Fi connection, or you can join your phone or have maybe a hotspot that you use. So again, I can turn it on, turn it off, and actually determine what my results are. The Gauge Remote app is available for Android and iOS, so it's something you can download and add to your device easily. And you must remember that whatever device you're using and the gauge must be on the same Wi-Fi network. That's the common thing that people think happens automatically, and it does not. So if you want your gauge to join a specific Wi-Fi and it has a security requirement, it has a password, you need to use the configurator. We have lots of other webinars describing that, or you can reach out to Jay. But if your Wi-Fi is open access, means no security, no password, you can easily join between the gauge and your device. So another way that you can use your gauge remote is if you do smoke the ducts, smoking the ducts. That's what I said, smoke the ducts. And that a lot of times you want to know where the smoke comes out of. It's hard to see that. So what I can actually do is put myself in the position where I want to see the greatest impact, and then actually put the smoke in my duct tester, and then go to another area and actually activate the duct tester. I did mention this earlier, that the virtual gauge and what it can do in terms of multiple fans using your PC. This actually is a direct download from Retrotec. You can go to retrotec.com and download the app directly from their software page. And again, it allowed me to do things like this, which are pretty phenomenal. Fantastic has joined the Duct Club, which means that Fantastic also can do a variety of duct leakage. It also does what the Pacific Northwest does, is actually does their duct test at 50 pascals. So it allows you to do it at 25 or at 50, and also does commercial duct testing automatically with the Fantastic software. So again, it clearly covers residential and commercial duct testing. Instead of doing dominant duct leakage, I'm going to switch over to something I think is even cooler.
Joe, while you're switching over, I want to explain something. There was a question real quick that took a little too long for me to type out, so I'm just going to explain it verbally. Guy has a question here. What is the difference between our Cloud and Gauge Remote app? And I can speak to that. So the Gauge Remote app is a app for your mobile device. It can be any kind of mobile device that you have, and essentially it's going to replicate your gauge, your DM32 gauge. It can only connect one-to-one. It can only connect to one gauge at a time, and that gauge can only connect to one mobile device at a time. And basically, you can just it's a remote control. However, our Cloud is a app that is also on mobile devices and on a PC, and it can independently run any number of tests itself. It finds out your geolocation. It and creates a pretty rich report that tells the test, how the test was run, where it was run, what the house was like. Can add photographs. So it's a far bigger, more robust type of app for creating compliance reports.
We describe the R Cloud as actually it's a platform. It's not just an app, because there's several apps out there that can either maybe control your fan. Energy Conservatory is one that can also do kind of automated testing. It will do automated testing, but the difference is that what you get on the back end is an entire support mechanism that actually can allow you to access all of your tests and see them from your a web portal, and give you a lot more options. So that's one of the main differences between just a simple app and something that actually gives you a lot of great opportunities to do more with your data. Okay, so I did this a 3D model, so I thought I would describe what's going to happen here. Is we're going to do a leakage outside test with some cool SketchUp effects. All right, so let's give some references here. So the red is your supply air, and the blue is my return air. And we can now start moving throughout the house and see what happens in the attic, which is where some of my duct system is, and there's also some that's on the interior. And as you spin around, we can also start to see when my system is on what kind of leakage I have. So again, red is supply leakage and blue is the return leakage. One of the things you can do with SketchUp that sometimes is hard to do with your regular pictures is to do stuff where you can zoom in and actually show that where your boot connects to the drywall can be a significant issue in terms of leakage. So this is actually something that was easier for me to illustrate than sometimes take a picture of, because it's hard to take a boot and cut a bunch of drywall around it. I probably can make a prop, but I thought this was easier to create. So this is the most significant area of leakage for blower doors and duct testers. If you're failing, there's a high probability that your ducts, your boots are not sealed to the drywall. So if you're working with builders, this is a priority. In fact, many codes are describing that this is actually an actionable item. You must check this off or confirm that boots are sealed to the drywall. Okay, so we go back in, we can kind of see where our normal supply and return is working. And here's the leakage that we actually have that's considered indoor leakage. Again, red is supply and blue is a return. And there's how leaky our system is. It's probably a fairly common system that's leaking. So now we're going to set up our tests. We seal off all of our ducts as we normally do. We're going to install our duct system and our flex duct. And we can pressurize or depressurize. All right. So again, remembering that the fans must be doing the same thing together. So most people consider pressurization as the thing that's easily to visualize. So we're going to start with that. Right. So again, we're going to show our system how it works when it's pressurized. And again, we have all this leakage. I turn my duct system off. So I just did my duct leakage test. So I said, okay, here's my total leakage. And now I turn my system off. I turn my blower door on. And remember, I'm pressurizing the ducts, means I must be pressurizing the interior of the house. So blower door's on. It's pressurizing the house. And here's your pressurization. And here's the cool effect that happens. We have now neutralized the pressure that's inside the structure itself. And now the duct tester is on, and notice that I do not have leakage inside those ducts in the wall. So this leakage that's here has been eliminated.
That's awesome.
So now the only thing I'm measuring is now this leakage to the outside. So this is the concepts that are. I still have this leakage around the boot. It doesn't leak to the interior anymore. It now leaks only to the attic. And here it is the concept. I have a whole another series that I can do that is specific to the depressurization, but instead I want to move on to something I made last night to add to this, and that is that if you are, how many people out there are trainers? Give us a nod if you're a trainer, and are you familiar with the simulators that Retrotec has? Because I'm going to go through what they look like and how to do leakage outside with your simulators, because it is a difficult concept to understand unless you've actually done it or see it. So this is the concept we're after, and let's just start with the simulators. The blower door simulator is something that everybody loves. It is a major popular training tool. We use them at our booths. I can't say enough about this. Just so you know, it equals approximately 1,000 square foot home. So the kind of leakage you can get is equivalent to that. So I can put the blower door in and pressurize, and notice that there's these sliders on the side that give me some of the options in terms of leakage. So each student can come up and actually get their own leakage or own results, or you can change it on the fly as the students are doing their tests, wondering what just happened. So it's designed for the actual person to set up a real blower door, the frame, the cloth, and put the blower door in, run it with the cables, everything that's very similar to what you normally would do in a house. And that's kind of the scale that's out there that we have. You can also depressurize with the system itself. So you have options. It works better with pressurization than depressurization, but you have those options. This is the duct tester simulator, and it's identical size to the case you probably have. They also just added a grill on the front so that you can actually set up your duct system to it, and it's got sliders on the side in the same manner. If you're looking to get a new duct tester or the simulator, you can order that. If you want to get a new duct tester, you can say, I'll pay the small fee to add it to a simulator case, because you can just use this as a normal case. So I can use the simulator case to do pressurization or depressurization. And I can also use these together. So some people that do IDL, that was one of the ones that's on my list. The IDL, the BPI infiltration duct leakage requirement requires you to do blower door test, total leakage, and leakage to outdoors. Most people use a real home. Sometimes you may not have access to that, but you can use a simulator as a trainer for IDL testing, right? So here's the concept, is that these are both connected through a slider on the side. So I'm now connecting the ducts and the house simulator. And again, most things, both things must be doing the same thing. So if and this is the key to this, is that don't look at them together. Look at each one of them as an isolated test. So here I am pressurizing my system, and the same with the blower door. So if I set the blower door up, now I'm pressurizing, and so is my duct system. Right? This will give me leakage outside. So they each have a gauge. I don't have a gauge next to the duct tester, but they each have a gauge. They're both doing leakage outside. So here I would be turning on the blower door like I normally do first. I go to the duct tester, set to 0, and I'm good to go. You can do add the extra tubing and go 25. It's a little more complicated. That's why I recommend, especially for this, just stick with set to 0 and you're good to go. So here we go with some scale. Here's our guy. This is Joe Tester. He's back. And I can do the same opposite where I am depressurizing. Right. So if I'm going to depressurize, I have my blower door depressurizing, the duct testers depressurizing. And again, remember, it's all based upon you're standing in the house. When you look through the little window on the cloth, that is outside. So the simulator is outside. We're standing inside all the time. So now I have actually blower door first, duct tester, and again, I'm standing inside the house running my test. So if you want to use the simulators, that's it. The key to remember is just look at the blower door and determine what kind of test is it doing. Just look at the duct tester, what kind of test it's doing. If you're trying to look at them in terms of, wait a minute, I'm pushing air and pulling air, it will be a challenge for you. I can give you the hint that usually my sliders are fairly low, and the slider that's between the two of them is about halfway up. And you can adjust that in terms of how much leakage I have for each one of them in terms of blower door, duct, or leakage between the two is leakaged outside. I'm 6 minutes over. I apologize. I've been trying to stick with the hour, and that is where we will sit. Any other questions, Jay?
No questions. Just you got rave reviews on the Sketchup show. Everybody thought that was awesome.
Great. It was. I think it's a lot easier to visualize things when you can visualize them 3D.
So are the Retrotec blower door and duct tester SketchUp models available for download is one of the questions.
I will do that, but Jay and Kirsten, my Retrotec direct overseer person who says, Joe, here's what you need to do. We'll make sure we do that, but it will probably be about 2 weeks. But what I'll do is I'll set up a series of pictures and an animated GIF between the leakage outside and the actual simulator so people can see that.
Joe, I think we covered pretty much all the questions. Seems like it went pretty thorough. SketchUps went well, and we got some pretty good suggestions here about things that that we can do to kind of to make it even better, which means which is greatly appreciated. But thanks everybody, very active crowd, and I hope everybody found this helpful.
Appreciate all your questions, great feedback. Steve, Cohen, and Rob, excellent for all your feedback in the background, and everybody. We will record this. We'll get it up. Usually takes about a week or so. And look for our newsletter if you're looking for more, or go to Retrotec for their webinars. We usually try to do at least 1, maybe 2 a month, and we'll go from there. Jay, thanks for your help in the background. It was huge, and I'll see you next week. Goodbye, everybody.